Okay, again, here's question 5, one of the nastiest ones, but basically it was looking back at a lot of the whole assignment 1 with the Ngon creation. Basically, what it is using the very similar to creating the Ngons, it's having the whole math for creating as close to a perfect circle as possible, but using that for a vertice generator, and then arranging said vertices within the triangle list in separated by 3 parts. In the top, the mid, and the bottom. Mid is more so, I guess you could call it a carpet for rolling up a dead body, and the top is like a hat, and bottom's like shoes. So basically the top is combined together in such a way that has a downward facing semi-sphere, and then the opposite for the bottom. In this case, enabling here, it's a 12 by 12. And as for streamlining, within this and the other, in number 4, there's a lot of more or less duplicated code, or at least multiple for loops that could be condensed down via usage of a function or two, or creating custom functions to deal with these for loops. So it's a shorter, more condensed method, so to speak. Okay, here's number 4. Number 4, what was done was the actual vertex creation was copied between the two, but the blob pointer, the ID3D blob pointer was, the name was changed only so it wouldn't yell at me, but also so it could have a physical difference between which shader is which. They both share the same layout and the same pixel shader, and that came to be from a little bit of experimentation that only a pixel or a vertex shader needed to be switched. Here's setting for active, calling the models. Oh, I already went over number 3, I think, in one of the other videos, but whatever. So basically, the further question for this is, within the actual P model, the pointers of P model to the same, I guess, prefab itself could be reused by multiple shapes, only because the actual vertices aren't being changed. Instead, they're being transformed by applied world matrices and applied colors, or I guess vertex colors. But that's all outside, like, post creation of the actual models themselves. Here is the creation of the simple color buffer, I want to say. I brought in the actual old struct from the first question, only because that actually worked with Simple Color 3D, and I made a new buffer, and after setting up that buffer within the actual draw scene is where the switching begins. So first is regular color selected, so we've seen that all before with the whole get your data, your world color data, set the world, the actual color, and then render, and that happens for 2. But then when switching is setting up the, I guess, internals for the actual, what is it called, simple color shader. Essentially to set the constant buffer to always be the buffer we set up earlier, and then calling upon the actual render of the same models, but using different world matrices and technically different color vertexes because of how Simple Color 3D is applied. Only weird part here is I kept crashing without recycling or like resetting the shader back to color select. It probably has to do with the whole the drawable loop needing to match when it restarts. So run this real quick. While we wait, this is probably a good time to address the second one. The second question for a... Oh, yeah, see there's your 2 and 2. Now it's probably a good time to address the second question being the whole how to streamline a shader and all that fun stuff. So the best possible way to streamline a shader is very similar to how this came to be, in having similar formats for the actual layout, so it only has to be computed once. But for this here specifically, it could more. I was thinking to make a actual function to take in an iBlob pointer, the file name, and that's actually about it, because these could be written out as functions themselves to spit out the data needed. And then the same could be said for the layout and the pixel shaders. Past that, the actual within Drawable, I feel that the creation of each object could be condensed down into a specific, I guess, draw object function based upon the current constant buffer being set. More importantly, the conversion needed for the simple, whatever it's called, not whatever it's called, the simple color 3D could be condensed down into, again, its own function. Okay, so let's go quickly into 3. 3, the main point here is multiple matrices, and then again just copying and pasting the object render code, but changing the world matrices and changing the color. Very simple. Okay, we're back, running low on time. There's a 3. Then there's number 2, which is simply creating a unit pyramid, which is simpler, not simpler, it's similar to the unit box, only it's less vertices to track and less triangles, because it's creating a square, a flat square, and connecting all those vertices to a single point above it. And there it is. There's the triangle. And last but not least is question 1. Sorry for going backwards in this, but all that was changed was splitting up the actual... Hello? Why is it not responding? Okay, slight hiccup, but now we're back. So the very last thing was splitting up the matrices struct into cam data and world data, reflecting that in the simple color again, and then within the actual application, splitting up the, I guess, not asserts, but splitting up all the values between the proper data structures. So camera data got the view and projection, and then world data got only the world. And to show that it works, I'll load and call it a night. Okay, last cut in because it was taking a while to compile. Look at it. Cool.